Over the next several minutes, we're going to discuss insulation requirements and proper air sealing methods. The 2012 International Energy Conservation Code stipulates that residential homes in Maryland be tested and verified as having an air leakage rate not to exceed 3 air changes per hour when tested at a pressure of 50 pascals or 0.2 inches of water column. This can present some challenges. Our goal today is to limit those challenges by showing some of the air leakage paths into the homes and proper insulating methods. Design professionals are accustomed to designing homes to keep water and moisture out. Now they must also design to limit air infiltration. Starting in the basement, and we're talking about unfinished walls, it's important to note that in Garrett County, the requirement is for insulation to be an R15 or greater. In all other counties, it's R10. The insulation should start at the top of the wall and go 10 feet down or all the way to the floor, whichever is greater. When we're addressing the band board above the foundation walls, builders have a tendency to have them insulated to the same level as the foundation. However, because there is no concrete foundation behind this band board, it should be insulated to the same level as the above grade stud walls, in this case an R20 or greater. Often on a foundation wall, penetrations are forgotten with regards to air sealing. In this case, this is fresh air and flue vent going to the furnace. All utility penetrations in the band boards and the foundation walls must be sealed. Another area that's often forgotten in air sealing in the basement or foundation are the windows and doors. These windows should be caulked or foamed in place to limit air infiltration. However, keep in mind, use low expansion foam so as not to warp the window frame. Looking at this section of wall, we can see numerous wires that are coming out of the basement and up to the second floor. Starting at the bottom, you can see where air sealing has been performed using spray foam, and it's important that it also be sealed at the top section. This limits the amount of airflow between the stud cavities. Additionally, you can see that each stud cavity has been foamed as the wire passes through it. This limits any air infiltration from going from one stud cavity to the next, where air to somehow infiltrate into one of the stud cavities. Insulation in the stud cavity walls above grade must be R20 or greater, or have an R13 within the wall and an R5 continuous insulation on the exterior of the wall. To properly install the insulation, it must be installed to manufacturer's specifications. One of those specifications is that it be cut around wires. As you can see, we have an electrical wire running through this wall. As the insulation is placed in the stud cavity, if a cutout is not made in the insulation, as has been done here, and that insulation tucked behind the wire, then we run into a situation where the insulation has formed a gap where that wire comes through. This reduces the effectiveness of the insulation within the stud cavity wall. The wall between the garage and the house can be challenging with regards to air sealing. All doors must be foamed. All bottom plates of the wall must be sealed with either caulk or foam, and all penetrations for utilities such as electrical, gas, ductwork going to the second floor must be sealed as well. Additionally, one of the most challenging points is the blocking at the top of the wall between the second floor floor joists. As you can see here, the floor joists have been foamed in place and the penetration of the beam above has been caulked and foamed as well. This limits airflow along the floor joist and into the house. Now we're standing in a closet above the garage. As quite often is the case, there's an attic knee wall behind this insulation. It's important that a solid air barrier be placed behind that attic knee wall. This not only supports the insulation as it's installed in the wall, but stops the air from infiltrating through that insulation. As you can see here, this builder has installed an OSB air barrier behind his insulation. In this particular house, with approximately 1,100 square feet on the second floor, there are over 65 penetrations through the ceiling plane. Between the lights, sprinkler heads, and ductwork, as you can see, numerous areas for leakage. If each one of those only leaks 5 cubic feet per minute, this house will very likely fail the air leakage test. Over the last several minutes, we've discussed ways to ensure a successful air leakage test and the Maryland insulation requirements. For additional information on compliance options, please visit the Maryland Energy Administration website at www.energy.maryland.gov.